But some danger awaits when we go to do the calculus, because as we already discussed earlier, this is bird. Bird is going to be sharp at 0 and is going to be not differentiable. So when I go to take the derivative of this, I get, I get 3 times the derivative of x to the 2/3 is 2/3 x to the negative 1/3, but then just minus 2. And if you simplify this, you get 2 over cube root x minus 2. And if that's the derivative, now it's time to say, when, if ever, is this derivative 0? I can just do this in my head from looking at it, which is that if x is 1, the cube root of 1 is 1, and so that this will be 0. So, okay, just like note from just like some common sense or whatever, that that f prime of 1 is 0. So that's one critical point. But what's important to recognize, unlike the previous problem, which was just a polynomial, so there wasn't really, you didn't have to worry about this. In this problem, you do have to worry about the derivative not existing. And in particular, the derivative does not exist when x is 0. If you try to plug in 0 into this derivative, you get undefined. So f prime of 0 does not exist. And so those are both critical numbers. Those are both numbers that we need to check. If you weren't just able to look at this and see that the derivative would be 0 and x is 1, you could, I suppose, just solve by saying when is 2 over cube root x minus 2 equal to 0? Well, that will happen when 2 over cube root x is 2. And that will happen when 1 over cube root x is 1, which will only happen when cube root x is 1, and that only happens when x is 1. So I just kind of did this sort of logic in my head a little bit. But alright, the big picture is I have differentiated, I've simplified my derivative, and I have found these 2 critical points. And so these 2 critical points must be checked. And by check, I mean we have to plug them into the function. So, well, f of 1 we already plugged into the function, but f of 0 we didn't. So, well, what is f of 0? And the answer is, it's 0. And therefore, what I now do, the final step, is to compare the value of the function at the left endpoint of the interval, the value of the function at the right endpoint of the interval, and the value of the function at the critical point, the new critical point, which is 0. And by comparing all 3 of these, I can tell you what the max and the min of this function is. This function is continuous on this interval, and so this function must have a max and a min, and it must occur either at the endpoint or at a place where the derivative is 0 or does not exist. And so from just comparing these 3 y values, I see that the min of f on the interval -1, 1 is 0, and that the max of f on the interval -1, 1 is the value at the right endpoint 5, or the value at the left endpoint 5. Okay, that's it. That's all I had to do. Last problem done. I will post this video now, and you will have no other work to do until Monday. Bye.